You might think an oyster is an oyster is an oyster. After all, oysters look pretty much the same.
Nice and juicy.
That's pretty.
But it turns out where an oyster is raised, in the wild or on a farm, and where it is from, the waters of New England, the Gulf Coast, or North Carolina, makes a big difference on the inside. That's especially true when talking about Vibrio, the bacterium that is found in all oysters.
We found that, yes, the bacteria are indeed in there, as you would expect with most places, but we found that our salinity levels, the salt levels of our state are much different than that of other states. We have the barrier islands in North Carolina, which affects our salinity levels. Not only that, our temperatures are a bit different. We're not as warm as the Gulf Coast, we're not as cold as New England, and it's that intertwining of the temperature and the salt level that produces a specific bacterial kind of profile that is different from another area. And so we're trying to really hone down what that particular profile is.
There are two types of naturally occurring Vibrio bacterium that is found in raw oysters. Both types can make humans very sick, and both types are found in warm coastal waters.
It's in the waters off Canada, the United States, Mexico. It is a bacterium. It is a natural constituent of the water. It is not something that you would find as a result of pollution. And the incidence of Vibrio grows strongest during the months of May through October because they're warm summer months.
But because the oyster is a filter feeder, which means it gets its food and oxygen by pumping water over its gills, the Vibrio bacterium becomes concentrated in the shellfish. And that's where science and seafood come together. Researchers want to design an early warning system for high Vibrio levels in oysters. And to do that, they're looking for a way to predict the Vibrio levels in the oysters.
If we can figure out the conditions that cause these bacteria to multiply, then maybe we will have an early warning of when to be careful of harvesting our oysters.
To be able to predict Vibrio levels, scientists must first determine what kind of Vibrio bacterium is inside the oyster, as well as the concentration. And to gain that insight into the inside of an oyster, scientists are applying the science of DNA sequencing. A tissue sample is taken from the oyster to extract and identify the bacterium's DNA.
We are looking actually for DNA of particular bacteria. Those bacteria are the ones that can make people sick. Those bacteria are the ones that can cause closures of shellfish or cause the product produced by the state of North Carolina to be unable to be shipped or consumed. And we combine these two methods to not only get an idea of the number of the bacteria that are in there, but the different types. Because the different types, as we found out, really affect whether they make you sick or not too. So it's not just the number, it's do there happen to be a high number of those more dangerous types.
Then comes the real number crunching. Scientists will have to correlate the records for temperature and salinity in the estuary's waters with weather patterns. Warm weather increases the water temperature. Rainfall decreases the salinity. Wind speed and direction can also impact water conditions. The challenge for researchers is to sort out the relationship between all of the weather variables and the concentration of Vibrio bacteria. The new testing procedures couldn't come at a better time. That's because the Centers for Disease Control have been tracking a dramatic increase in Vibrio infections. In fact, they are at the highest levels since 1996, when tracking of Vibrio first began. North Carolina's bays and sounds once produced hundreds of thousands of bushels of oysters per year, but pollution, overfishing, and disease took their toll. But the population and industry is coming back, and whether the shellfish is harvested in the wild or raised in a farm, the oyster industry is worth about $3 million per year.
The ultimate goal of this project is to have some sort of tool that will let us know, based on the conditions of a particular day, or it could be the conditions that were existed 2 days before, we're not sure yet. But to have a tool that lets us know that the oysters might be a little more dangerous for some people that might consume them than other days. If you close down a shellfish or oyster growing area, people are losing money. The sooner you can show it's safe and get it back open, the better both the industry and the consumer will be.
But even with a Vibrio warning system, the risk of eating raw shellfish won't go away.
And anytime you're eating any kind of raw or undercooked seafood, you are at risk for an infection or a foodborne illness. So we want to make sure that, first of all, we can reduce the incidence of either one of those organisms in the raw shellfish. And then secondly, we encourage people to cook their shellfish to make sure that they have eliminated the Vibrio threat.